Hello again. Thanks for joining this first session today at Industrial Wireless Forum, where we are to discuss some of the complexity to navigate hybrid cellular and non-cellular technologies in brownfield industrial environments, which are full of of course, their own legacy networks and equipment and data silos. But we will do this ostensibly through the prism of one particular private wireless deployment and a brand new one at that. So I'm really pleased to be able to introduce Peter Cappiello from US System Integrator Future Technologies, who you will all know if you read RCR Wireless, and Eric Winterberg from US Port Operator Total Terminals International, which operates along the US West Coast and is owned by Till Group, which is one of the largest port operators in the world. And Pete and Eric have an exclusive for us, no less, about their work together at the Port of Long Beach in California. And I'm here only really to introduce them and to maybe pick up some questions at the end. So please ask them in the platform as we go, and I will try to get to them in the last 5 or 10 minutes. But in the meantime, Pete and Eric, what a pleasure. Thanks for joining us. The floor is yours.
Thanks for having us, James. We appreciate it. Hey, good morning, everybody. Good afternoon, good evening. We're excited today to announce this great project that we're doing with Eric and Total Terminal out in Port of Long Beach, California. As James mentioned, we haven't really announced this project, but it's exciting, and look forward to discussing that case study today with the audience here. But Eric, maybe before we get into some of the other information, can you introduce your company and yourself to the audience, please?
Absolutely. My name is Eric Winterberg. I've been in the industry for a little over 24 years, the last 3.5 with Total Terminals International. We're based in Long Beach, California. We are the largest container terminal operator in the Port of Long Beach. Just a little bit about us. We are majority owned by the TIL Group, Terminal International Limited. And so we're just part of their portfolio, but the largest operator in their portfolio. They've been part of us for the last 7 years. Here at Total Terminals, we are looking across the board to modernize our terminal infrastructure applications, and we've been on a 3.5-year journey doing such. So it's a lot of fun. This project has been in the works for about 2 years, and we're finally starting to see it to fruition.
For you, Eric, though, it's safe to say this isn't your first ride on the rodeo?
No. I've been in the kind of industrial wireless arena probably since 2016, 2017. I worked previously for ATM Terminals, and we ran the global wireless product for there. We did a similar project in the Port of Los Angeles, although with autonomous straddle carrier machinery. So a little bit different use case than for what we're using. This one's a little bit easier, but nonetheless, very familiar with the space for sure.
Great. Well, just a quick introduction on Future Technologies for the audience, but we're a national lead system integrator in North America. Been doing connectivity transformation for the last 25 years. And in the last 15 years, we've been doing private cellular in these our strategic vertical markets to include transportation and maritime ports. But really excited today to talk about what we're doing with Eric and TTI. So we'll jump ahead. But as James mentioned, the focus of today's session is around brownfield connectivity transformation. So when Future Technologies looks at this, we're always trying to evaluate what's the existing infrastructure. So in Eric's case, maybe there's public cellular, there's Wi-Fi, there's a wired infrastructure. Why are we looking to add private cellular? So we kind of use this to visualize those different network layers, starting with public cellular, wired, fixed broadband, Wi-Fi, IoT. And for us, we're always looking at why private cellular. Is it coverage? Is it an advanced use case? Or in the case of TTI, I think we had the best of both worlds, where we're looking at both an advanced use case and a coverage scenario. And the byproduct of that is we're then able to leverage the existing infrastructure in that brownfield for its best purpose, kind of extending the usefulness by managing that, let's say, chemistry experiment. Our goal is to make it where the networks are high quality and lowest cost over the life cycle of these networks. So, in partnering with our clients, in this case, Eric and TTI, we think we've accomplished that transformation, and we're looking towards the future here. To basically bring this to life, what we've been able to do today is we've prepared a short video to show our living lab in Atlanta, Georgia, where we have Gary Hill, our Chief Innovation Officer. He was the former CTO of Georgia Pacific. He was there for 30 years. But we're going to actually showcase this brownfield connectivity transformation through a live video, and then we're going to come back to Eric and discuss his project specifically.
Hey, welcome to our webinar today. Gary Hill, Future Technologies Chief Innovation Officer. We're going to do a quick tour of our living lab here at our headquarters in Atlanta, Georgia. We're going to start in our Network Operations Center monitoring room. So here's where we demo the software where you can monitor your private networks, your industrial routers. So we're showing like the Nokia Index system. Dan, if you come a little closer here, we can actually show the status of our system remotely. Look at the status of the SIMs, look at the status of the CPU on the core software. Here's an example of the industrial router software. So this is an industrial router that we're running in most of our port operations to connect the lift devices to the private networks. I can see status, do system upgrades, do factory resets, reboot the devices remotely. This is a partner one layer where we can actually get deep visibility into the devices on your private network. This example here is showing the Nokia industrial routers. So now we're in our edge compute room. Here's where we run the hardware and software for the private software for our private networks. So we also have some portable kits in addition to rack-based kits. So these kits we can take on the road to trade shows, to customer sites. So here's a Nokia 5 system in the rack. I'll show you what it looks like over here in a production implementation. Typically, these would go in an edge compute room in your data center. So again, here's the same type of system here, racked in your computer room. Radios are actually outside in the lab broadcasting, so we can do device testing. Hey, now we're in our tower training area. This is a place where we train our field service technicians to learn how to climb towers, do our safety training. We can pan up and show the towers. This is for outdoor implementations where we put the private network radios. We can also help customers build towers so they don't have these assets at their facilities. So this is the arena area where we have use case set up for demonstrations on our private networks. We also have towers here running the radio networks. We're going to take a quick look at one of the towers here. So this is where we mount the radios for, could be private cellular, microwave. We even have Wi-Fi here. You see a camera, so we're doing some computer vision applications in the environment as well. We'll hit some use case tables. So here's an industrial IoT monitoring platform using LoRaWAN for sensors. This is an industrial vibration monitoring platform using sensors to do vibration off of large motors and equipment for predictive analytics. Another common use case our customers in the ports area have are really connected worker use cases. So connecting Zebra scanners, industrial handhelds, tablets. In some cases, we're even doing AR, VR headsets for the customers. We're also doing computer vision, as I mentioned the cameras earlier. So streaming cameras over your private network is a potential use case. So here's an example of this particular application doing people detection. You can see we're green, we're in a triangle. As we walk into that intrusion zone in blue, it can identify we've walked into maybe an unsafe area. So we could do alerting, monitoring here through that as well. Another use case we'll talk about is connected mobile assets. So in a port, it would be the lifts, the things moving, the containers around. Here in our warehousing environment, we have a connected fork truck. Very similar use case. We have an industrial tablet needing to access an application. Here, this is our warehouse management system. We're doing that over the private network through an industrial router. So again, connecting that to the moving vehicle, connecting into the battery system for power. Then we can run our application here. So this is, for example, the warehouse management system tells our guys to pick up and drop equipment in the warehouse. Also, an example, I can look at cameras that are on my network through my camera application. So again, very practical use case for industrial routers over your private network. So the last part of our tour tour is going to be to show you our lab on wheels. This is an investment we did with Intel. Pretty much everything you see in the living lab, we can take on the road, take that innovation, take the use cases, take the networks on the road to customer locations. So lab on wheels, 16-foot trailer. We'll take a quick peek inside. Equipped with battery power, so we can run a few hours offline. We also have Starlink for internet access. We have several cases here of use cases, so industrial routers, a LoRaWAN, various things. Also have a small rack here, so we can bring edge compute with us. So that computer vision application you saw, we can actually take that and run at the customer site. Here's an example of another portable kit. So we could take this. Actually, we did take this to a port about 30 days ago in the New York area. We actually put up a temporary mast about 40 feet, actually broadcast private cellular into the environment. We also have a small workspace here. We can talk to the user, talk to the customer about applications, show the demonstrations. Anyway, appreciate your time today. I'll turn it back over to Pete for the rest of the webinar.
Great job, Gary. We appreciate the live tour. But you know, Eric, after seeing all that, it'd be good to, you know, dive into your case study, and maybe if you could give a little backstory on, you mentioned it's a multi-year process, but, you know, I think you were looking at Wi-Fi, evolving, did some RFPs. So maybe, you know, we've already done the customer profile side, but maybe if you could, you know, through your prism as the customer, what did this journey look like for you?
Yeah, it started with when I first joined the company, we were going through a fluid mesh deployment, and obviously our industrial wireless wasn't meeting the needs of our application and customer or user experience. And so after several months of that deployment, we felt it wasn't going to scale to the whole facility and meet all the use case needs. And so we originally looked at a traditional Wi-Fi 6 solution, and we felt it was going to be a detriment to our future needs, meaning that it required a lot more light pole and access point densification to get the same kind of coverage. So we partnered back with TIL and we really kind of sought out a private cellular network solution. Here in the Port of Long Beach in Los Angeles, there's a lot of interference, both from the commercial base with being 12 operators in the region in a very small area, plus with the U.S. military. It creates a lot of noise and interference amongst the terminals. And having a private cellular network really gave us that ability to reduce that noise, but also less of a infrastructure footprint to broadcast signal and connectivity through the machines. So once we've set forward on that journey, we then, with our experience in doing these at similar locations, we looked to partner with an implementer that had the experience of doing large-scale industrial projects such as this one.
So just for the audience, because you know, we have a broad range here, but starting with Fluid Mesh, which is it's an 802.11 Wi-Fi mesh solution, was the starting point. Then Eric looked at an 802.11 Wi-Fi 6 solution as maybe a net new product, and ultimately pivoted to do private cellular. I guess it really came down to coverage and mobility, you know, being, you know, key characteristics of private cellular.
Exactly. Yeah, I think our biggest use case, as you can see from our picture there, is we have over 400 units that transmit work instructions to and from the railroad, the ships alongside, and the gate traffic coming in and out of our facility. And so those work instructions tell the operator what container to lift and where to place it. And when you lose that connectivity, it then takes additional manpower to figure out where, in fact, that container might be. And so by having something that's reliable and not only coverage, but connectivity is the key. it allows us to streamline and make that more effective solutions across the.
Yeah, and well, I think resiliency is also important. So, like if we look at this notional network diagram, you could see, we accounted for frequency resiliency, where we have both CBRS as well as a license band, in this case, band 53. That's kind of on the left-hand side. In the middle, we're deployed at your MDF location with high availability on the private cellular core, as well as the firewall and router. I think, the nature of this being mission critical and you running your terminal operating system there locally, us being able to match that and provide high availability on the wireless layer, on the infrastructure layer there at the edge was important as well to maintain the uptime that you're looking for.
Yeah, Pete, I think you bring up a good point. The ultimate why we settled on this solution was the redundancy to band 53. It allowed us, again, to keep that footprint limited to the number of light poles that would consume these APNs versus having redundancy back to traditional Wi-Fi. And so it lessened the amount of physical infrastructure that we had to put in place to have full resiliency and redundancy.
I think one other thing that I touched on earlier, looking at highest quality, and then providing a lower total cost of ownership. The stages that we've built based upon all the learning over 25 years, but going out, demonstrating things at a customer site, doing a factory acceptance test in our facility, showing up with basically radios ready so we could, basically fly the radios once we're there because they're pre-configured. And then ultimately partnering with your team, Eric, on the operation and maintenance side, where it's a shared responsibility, where you get to own the level 0, level 1. We're there to help as level 2, as your partner. And then we work with Nokia from a level 3 perspective. I think that blend is what makes it where, we're really partnering with you as the customer operating this network, kind of from design to, technology refresh in the future. But does that resonate with you as a customer?
Yeah, I think the methodology is what really sold us, especially on the factory acceptance testing. That allowed all of that pre-design to be validated, the network to be constructed and tested in a lab, which was a great asset to have, because in my past experience, most of that work would be done on site, and it becomes disruptive to the business. There's a lot of back and forth and fine tuning, whereas we did a bunch of the work as defined in the plan and design phase. While we did that pre-work, your team assembled the infrastructure and the network and fully tested the product. We witness tested, and then we came on site and installed. So I think that was really the best thing I've ever seen so far.
Yeah, and credit to your team. I mean, we were able to work parallel swim lanes where your team was doing some of the make-ready work in terms of the power and transport, and it's really a good collaborative, team effort. And maybe as we refer to collaboration, we'll bring James back into the fold to maybe ask us some questions. Looks like we have about 6 minutes left. So, James, welcome back.
Yeah, hi guys. Thanks. What a fab presentation, and thanks for the questions, everybody. We do have 5 minutes. I got a counter in front of me, so I'm gonna it's running out. But so there is a question here. It's an obvious one about Spectrum CBRS. You mentioned band 53 redundancy. Perhaps just explain what you're using for your Spectrum there.
Yeah, I'm happy to do an initial comment, but we've been able to design the network with two. We're using CBRS, which is a common industrial private wireless band in the U.S. Along the coastline, there is some coordination that's required, and actually, in Eric's case, we're right next to a naval base, so there's a consideration that has to be brought in for that. So we're kind of using that as the coverage and capacity layer of the network. And then from a resiliency perspective, we're using a 10 megahertz channel with Band 53 from Globalstar that provides a licensed band experience. So it kind of gives the best of both worlds. And as we deploy devices out there, James, we're able to support kind of primary, secondary RF bands, one unlicensed or lightly licensed in the case of CBRS, and then one licensed in the case of the Band 53.
So there's a follow-up question, Pete, Eric, about the cost return on the Band 53 and how you, I guess how you forecast that. At least is that just explain.
Yeah.
I mean, it just what.
I think we want to keep some of our secret sauce the secret sauce, but I would say that we're able to provide our contract with Eric is a 5-year contract. We Future Technologies are able to provide multiple different types of frequencies. We actually work with some of the tier 1 MNOs as well in the US, James, to provide different frequency bands. We have we have about 4,000 square miles of footprint in the Department of Defense where we're actually using tier 1 carrier spectrum. But we're there to provide the solution for the end user. So if it's the Department of Defense, or in this case, TTI, we have to build that as into the pricing for in this case, 5-year life cycle, and make it competitive to the market. And in this case, it went to a competitive bid. We were able to provide the frequency resiliency, the spectrum in that 5-year TCO analysis, and ultimately, was awarded a competitive bid. That goes back to we're striving to deliver the highest quality solutions, and then ultimately looking at lowest total cost over a 5-year term. That's usually what the contracts look like now. So that's all incorporated into that solution now, James.
Okay, I've just been told to move back from the camera, so if I get quiet, that's why. On the, Eric, you mentioned Port of LA or a port in LA. I don't know, but previous kind of experience with this kind of thing. You also mentioned that you were scoping out fluid mesh Wi-Fi 6, this kind of stuff. Was it ever in question that you were going to go with private wireless, having experienced that? And I guess as a follow-up question, and we are running out of time, why did you go with SI and not with Nokia directly, for instance? I understand you got some experience with them as well.
Yeah, so we did originally look at the Wi-Fi 6 solution, but it just wasn't proven in our business in a terminal in our market. Down the street in the Port of Los Angeles, I had experience with Nokia running autonomous straddle carriers through their new automation project that we had deployed. And so familiarity was a strong point. But when it comes to a service provider of implementing the solution, Pete and Future Tech have this industrial experience. They've done large scale projects beyond our industry into others. And there's a sense of comfort of having someone who knows the technology inside and out and has seen similar types of examples, maybe not in our industry, but has overcome these challenges and are subject matter experts. So that helps us move the product forward and really focus on the use case testing and that side of the equation, whereas our infrastructure network team really aren't that intimately involved in the designing of the solution. So that helps move at speed. And when it comes down to the resiliency and overall use, our use case, our productivity and effectiveness is having an accurate inventory, not only for handling of containers multiple times and reducing that multiple handling, but also delivering to our customers, whether it be the railroad or the trucks.
Eric, I've got to stop you. I've got Pete. I've got to stop you. I'm really sorry. We could talk all day. I'm sorry we can't. I've got a bunch of questions. We'll follow up separately of this and publish something. But look, guys, thank you so much. Fascinating, very interesting, really, really good project there. I'm handing over to Leo at ABI Research now, who's got a panel with XCOM RAM, Moso Networks, and China Mobile International about simplifying some of this stuff, as it goes, to help it scale, all that kind of thing. But that's it from us. Thank you, Pete. Thank you, Eric. And I will catch everybody a little bit later.
Thank you.
Thank you, James.
Thanks, James.